Alright, we're just going to dive right back in here, and we left off last time talking about the um, separation of the value from the name, or identifier, if you will. Click identifier here, bring up Wikipedia. What's an identifier in computer science? In computer languages, identifiers are tokens which name language entities. Some of the kinds of entities of an identifier, or some of the kinds of entities an identifier might denote include variables, types, labels, subroutines, packages. You could jump into all that stuff, but for our purposes, we're talking about variables. You see, brings us to this page, variable computer science. Click back, click back. That's where we started from. So obviously the concepts we're talking about intrinsically linked. Wikipedia, is it completely authoritative? No, but it's good enough. Um, in a peer-reviewed article, I wouldn't necessarily quote Wikipedia, but for our purposes here, certainly makes the point, serves to back up what we're saying in a concrete way. So, what did we say at the end of the last video? What we said at the end of the last video was that the separation of the value versus the name is the fundamental um, concept of variables in computer science. Or, I don't know if that's the exact words we use, but that's essentially the phrase that we were trying to express. So, first thing, we got to go over something real quick. I mean, I guess we have to go over a lot of things, but the next thing we're going to go over is that there are restrictions on what you can name variables. So, and there are reasons why that these there are reasons why these restrictions exist, and we're going to jump into that exactly right now. So, x equals 5 is a statement. The computer will evaluate that statement. When it's done, the symbol x will have the value 5, and anytime you refer to x after this statement, x will return the value of 5. So what do we mean when we say restrictions? What we mean is you cannot start, we're just talking in general terms here, there are probably some pedantic differences if you go to different programming languages and jump around in that context, but these are complex topics and we're trying to make them as simple as possible, and there's nothing simple about some of the basic concepts in computer science. Some are more simple than others, but so I'm kind of trying to abstract away some of the details that I can get away with abstracting and not having to go over. And so we're just going to say in programming languages, I'm not going to bother talking about, well, this one you can do it, that one you can't. I don't care about any of that. We're just going to pretend that variables in general in computer science cannot start with a number. Why is that? Well, say I wanted 5x, equals 2. Well, why can't I do that? After that, I just want to be able to refer to 5x, and I want the computer to replace this symbol with, similar to math, just like we talked about. I want it to replace that symbol with the value of 2. Why can't we do that? Because there's a kind of a simple rule that computers apply, sort of a litmus test, if you will. And again, maybe 5x is a valid identifier in some languages. I don't really care about that. We're not going to deal with that. We're just going to say that that's the rule. And basically, what the computer is going to do is, when you're putting in an expression and you're doing a simple assignment statement such as x equals 5, it's going to look at the first character, first letter of the symbol name. So let's make our symbol name, I don't know, some underscore symbol. So that's our name for the variable. We're going to assign a value to that variable, 1, 2, 3, 4, 5. So now, whenever we talk about, we could say, some other symbol equals some symbol plus 1. What's that going to do? Well, it's going to take whatever the computer evaluates to be the value of the expression on the right. It's going to assign that value, whatever this evaluates to on the right. It's going to assign that to this symbol name, to the name of the symbol. And whenever it sees some other symbol, it's just going to refer back to the value of whatever we calculate here. So we can get away with that. We can chain this together in all sorts of ways. We could have this, nested. Is the technical term. We could nest this as many ways as we want. We could have a value, or rephrase that. We could have a variable equal to a variable plus a constant, which no, that's not what we want to do. We could say that there's a variable, and we're going to assign a value to that variable of some other variable plus some constant, and then before the computer evaluates this statement, we're going to say, again, before it, we're going to say y equals z plus some other constant, and then before that, we're going to say z equals 0, and then so as the computer evaluates this series of statements or expressions, sort of an equivalent, the two terms are relatively synonymous. So when I say statement or I say expression, I'm essentially meaning the same thing. So z equals 0. Come down here. We want to make a new variable y. What's the value of y? Well, it's z plus 5. What's the value of z? As the computer evaluates this, it's going to sort of single out z and say, that's not an actual constant value. It's certainly not 5. It's not an integer. What is it? Well, it's got to be a variable. So I'm going to look up that variable value. Looks in the symbol list is what the technical name is, and say, oh, all right, z equal to 0. It's going to replace z with 0. It's going to add 5 onto it. It's going to get 5. It's going to come down here, find this other expression, x is equal to y. Well, what's the value of y? We'll get to that in a minute, but first we're going to take the value of 1, put it, that's constant, so we don't have to evaluate it. We just know that it's 1. What's the value of y? The value of y is 0 plus 5, which is 5. So x is going to be equal to 6. And again, you can string all kinds of statements and nest them. Again, z is nested into y, which is nested into x, and the term nest is maybe I'm using it somewhat out of context in this. I mean, it's generally reserved for recursive functions and things like that. You can look it up on Wikipedia, which jump into that, see if we can do it. Nest. See if we have any disambiguation here. We'll just type in nest. It's going to give us a bird's nest, which is not what we want. Science and technology, nest software, no. Nesting, disambiguation, nestling, nested. Go with the disambiguation here. Kind of digging around. Building or having a nest, nope. We're not a bird. Nesting, computing, there we go. So, computer science, the word nesting may denote several different constructions and activities where information is organized in layers or objects contain other similar objects. Term is thus used in quite specific ways for various situations and concepts depending on the context, which is sometimes only remotely related. Wow, that's abstract. It almost always refers to self-similar or recursive structures in some sense. So, again, if you want to be pedantic about it, am I misusing the term nest in what we just explained as far as going over this? Maybe, but it's not important. So, back to the rules. There are rules about what you can name variables. Those rules exist for a reason, and basically the rule here is that you cannot start a variable name with a valid constant value. So some symbol equals 1, 2, 3, 4, 5. That's valid. Some other symbol equals some symbol plus 1. That's valid because the compiler can come in, or sorry, not the compiler. Kind of revealing my C roots there, but the computer can come in and say, what's 1? 1's a value. It's a constant. I know what the value of that is. It's going to come over here and say, what's some symbol? Well, I'm going to look up in the symbol table. I find that name in the symbol table. Some symbol. What's the value of that? It's 1, 2, 3, 4, 5. It will substitute that value in here, and then it will complete the expression, do the calculation, and assign the result of that calculation onto some other symbol. Now, if we were to say for some other symbol, I can type some other symbol equals 0. In a general sense, as we talked about, generally speaking, this is not valid. The first character, the first letter, if you will, is a number, and as a general rule, computers do not allow that. And the reason is because there's technical reasons for it, but basically, we're just going to say, I'm probably going to be the one point in the video series where I'm literally going to say, I'm not explaining that, and that I'm not going to explain it. So, I'm not going to explain why. Again, this may or may not be valid in some, most, all programming languages. I don't really care. For the purposes of what we're talking about here, we are going to constrain ourselves to the rule that you cannot start a variable name with a constant value such as a number. So for some other variable, not valid. For x equals 1, for y equals 2, for 1000, z equals 0, all not valid. We're also going to impose a, just bring this up real quick, see what we got. It's about 10 minutes, so we got about 4 minutes left. Similarly, we're also going to impose a rule upon ourselves that we can only use the letters in the alphabet. We cannot use punctuation. So for period equals 0. That's not valid. We're just going to pretend. We don't actually have to pretend because I don't think that that's a valid identifier in any language. We're going to say for period or 0 period. Anything that, even x period, doesn't matter what it starts with. Period is not valid in a symbol name. There are various reasons for that. You can look up classes, objects, things like that. It won't, when you, even if you start reading Wikipedia articles on classes and objects and things like that, it won't be immediately obvious why period's not valid in most computer language or most programming language identifiers, variable identifiers. But suffice to say that it's not. See what else. Space. Obviously, space is not. You can't say x space equals 0. Because the computer will just strip away, spaces. So, I guess it's as good a time as any to say, you could put it, frankly, you could really put as many spaces as you want. Say, x whatever is 1,000 spaces, or 25 or whatever it is. X equals 0. What's the computer going to do when it evaluates or reads this entire expression? It's going to strip the white space, and what it's going to actually do is it's only going to read that. So I mean, it's going to take a 30 to 40 character expression, and it's just going to strip it down to the simplest representation that it can. And part of that process is getting rid of white space. There's other things that it does, but so hard and fast rules here. Variables, variable names, as it were, which are on the left side of the expression. Variable names cannot. See, variable names cannot start with numbers. Variable names cannot contain punctuation, single quote, double quote, backslash, the tilde key, the period, the comma, hyphen, anything like, etc., etc. Anything like that, not valid. You cannot use that in any variable name. That's a hard and fast rule. And the one exception, because there's always exceptions, is the underscore. That's not only can you use the underscore in a variable name, but it's encouraged. So if you have a variable, why do we use the underscore? Why is it the exception? Well, basically, let's do a quick check on the time here. Got coming kind of dangerously close. We'll come back to this in just 1 second.